Hi, I'm Aries, a postdoc at the Neural Systems Lab at the University of Washington. Today I'll be talking about recursive neural programs, a generative model for parsing objects and scenes into part-whole hierarchies. Human vision involves generating conceptual objects and relationships between them. A key feature of animal intelligence is the ability to synthesize new objects hierarchically using existing primitives and relationships. A Segway, for example, can be understood as a synthesis of wheels and handles, but each one of these wheels and handles are the syntheses of other objects. We can express this as a trees of programs, each consisting of state and action transition functions. To make the model recursive, each state or patch can be thought of as a program that generates itself through a composition of primitives. Applied to these MNIST digits, each patch that makes a whole digit can be generated as a program of transformations of smaller patches. We could do this by passing each state through a hypernetwork, which generates state and policy functions that map state action pairs into new states and actions, composing them sequentially until the program is complete. We could do this recursively by feeding each state Z into the hypernet. The explicit compositionality and recursion of our model allows it to express unseen objects as transformations of known primitives, enabling zero-shot learning. Here are some examples of zero-shot learning with RNPs trained on MNIST digits instead of 7 or 8, or on unseen omniglot characters. We're working on expanding our model to incorporate dynamic inference during generation. With this, I'd like to thank you for your attention. Thank you very much.